Your data doesn't always go to the cloud. Sometimes the cloud comes to your street, and that changes everything. Your gaming lag, your smart camera, your self-driving car, even how AI runs on your device. In the next few minutes, you are shown how the internet quietly evolved from faraway cloud servers to local mini-brains near you. You'll see why edge computing was born, how it evolved, and why AI is making it more important than ever. For years, the internet trained us to think like this. Device sends data up, cloud processes it, result comes back down. That model is amazing for storage, large-scale coordination, and heavy computing. But it has one weakness: distance. If your smart camera detects a break-in, if a factory robot must stop instantly, if a car needs to react in milliseconds, sending everything to a faraway data center is not always good enough. That's the basic problem edge computing solves. Process data closer to where it's created, so decisions happen faster. To understand edge computing, you first need to understand the age before it. In the early cloud era, the big idea was centralization. Instead of every company running its own complicated infrastructure, you moved workloads into giant data centers. That was efficient. It scaled beautifully. It helped launch streaming, SaaS, mobile apps, and modern internet business. But then the world filled up with smartphones, sensors, cameras, vehicles, machines, and connected devices. And suddenly, the cloud had a traffic problem. The issue wasn't that cloud failed. The issue was that some decisions needed to happen much closer to the action. One of the early turning points came from the idea of cloudlets. Researchers at Carnegie Mellon describe cloudlets as a way to bring cloud-like resources physically closer to mobile users. Their Living Edge lab traces this research back to 2009. In simple English, don't make your phone run all the hard work alone, but also don't force it to travel all the way to a distant data center. That was an early big aha. Maybe the internet doesn't need only one giant brain. Maybe it needs neighborhood brains. Then the idea became more structured. NIST's fog computing model describes a world where computing isn't just at the far cloud or at the device. There can also be an intermediate layer closer to endpoints. This matters because not every task belongs in the same place. Some tasks need instant local response. Some need regional coordination. Some still belong in the cloud for large-scale storage, training, and orchestration. So Edge wasn't about replacing cloud. It was about reorganizing the internet into a smarter hierarchy. Then telecom took the idea even closer to real time. latency defines multi-access edge computing, or MEC, as cloud computing capability at the edge of the network, especially useful for ultra-low latency and real-time applications. That means the edge can live inside telecom infrastructure itself. So when people say 5G is not just about speed, this is why. It's also about where computing happens. By now, edge computing wasn't just a theory, it was becoming necessary. If you process data closer to the source, you often send less raw data across the network. That means less congestion, less delay, and in many cases, better control over sensitive data. And for some environments, factories, hospitals, vehicles, stores, oil fields, ships, rural locations, connectivity may be weak, expensive, or unstable. So edge computing is not just about speed, it's also about survival in the real world. Now here's the plot twist. Edge computing got even more important because of AI. NIST describes edge AI as a growing frontier, where AI functions run on edge nodes and user devices. And today, Google, Microsoft, Qualcomm, NVIDIA, and others are all pushing on-device and edge AI stacks. This is a major shift. Why? Because AI loves immediacy. If an AI model helps a smart camera detect danger, a factory machine avoid failure, or a phone summarize speech in real time, you don't want every inference taking a round trip to a distant server. You want the intelligence right there. So the evolution looks like this. And today, the most powerful version isn't cloud versus edge. It's cloud plus edge. The cloud still trains giant models, coordinates fleets, stores history, and handles heavy analytics. But the edge increasingly handles the urgent moment, the decision that cannot wait. So edge computing is really the story of the internet growing up. It started as a world where everything had to travel far away to think. And it's becoming a world where intelligence lives closer to people, places, machines, and moments. Subscribe for more hidden tech systems shaping your everyday life.